Hello my dear students, welcome to my physics class. Our today's topic is representation of vector with components. Let's start now. At first, we will discuss about rectangular unit vector, and already we know what is unit vector. The vector of magnitude unity is known as unit vector, that is the vector whose magnitude is 1 is unit vector. Three unit vectors which are considered along three positive axes of three-dimensional Cartesian coordinate system are called rectangular unit vector. We know in three-dimensional Cartesian coordinate system, three mutually perpendicular axes, x-axis, y-axis and z-axis, and three unit vectors are considered along these three axes. That is a vector, a unit vector in x-axis and another in y-axis, and last one is along z-axis, and these three vectors are known as rectangular unit vector. Here x-axis, y-axis and z-axis, that is this is the three-dimensional Cartesian coordinate system. Here three mutually perpendicular axes, x-axis, y-axis and z-axis, and along x-axis I unit vector is considered, along y-axis unit vector j, and along z-axis unit vector k. That is I, j and k, these three unit vectors are considered along x-axis, y-axis and z-axis respectively. A vector in two-dimensional coordinate system, and here a two-dimensional coordinate system is shown. Here two mutual perpendicular axes, x-axis and y-axis, and we know along x-axis unit vector is I and along y-axis unit vector is j. And here OP is a vector and OA is the tail of the vector and P is the head of the vector, and the coordinate of P point is AX, AY. Now we'll draw a perpendicular PM on OX axis, and here OM is the component of P vector along x-axis, that is here OM is equal to AX, and another perpendicular PN on OY axis, so ON is the component of P vector along y axis, so this is AY, ON is AY and OM is AX. According to triangle law of vector addition, we can write here OP is equal to OM plus MP. This is the triangle OMP triangle. So according to triangle law of vector addition, OP is equal to OM plus MP. That is OM plus ON. We know MP is equal to ON, so it is ON, and OP is a vector, and here OM is AX and OY is equal to AY vector, that is AX vector and AY vector, and we can write this AX vector as AX is its magnitude and I is unit vector, so AX vector is AX I and AY vector is AY j vector. Here I is the unit vector which is along the x-axis and j is the unit vector which is along y-axis. So we can express this A vector with its components, that is A vector is AXI plus AY j. This is the representation of a vector in two-dimensional coordinate system. That is, along x-axis its component is ax, and along y-axis its component is ay, and a vector is axi plus ayj. Now magnitude of vector. From figure we can write OP square is equal to OM square plus MP square, because it is right angle triangle, and from right angle triangle we can write OP square is equal to OM square plus MP square. And we know OP is equal to A, so A square is equal to AX square plus AY square. We know MP is equal to ON is equal to AY, so it is AX square plus AY square. Therefore we can write A is equal to root over AX square plus AY square. Unit vector along or parallel to a vector. Now we will determine a unit vector along or parallel to a vector. A unit vector along or parallel to a vector is, we know A is equal to, it's a unit vector, and if we divide a vector with its magnitude, we will get a unit vector along that vector. So unit vector along a vector is a vector divided by its magnitude A. So we know A is equal to AXI plus AYJ, and its magnitude A is equal to AX root over AX square plus AY square. So unit vector along a vector is AXI plus AYJ divided by root over AX square plus AY square. Now a vector in three-dimensional coordinate system. Already we have determined a vector in two-dimensional coordinate system A is equal to AXI plus AYJ. Now we will express a vector in three-dimensional coordinate system. Here three-dimensional coordinate system. Here Cartesian coordinate system, and three mutually perpendicular axes OX, Y, and OZ. And along OX axis unit vector is I, along OY axis unit vector is J, and along OZ axis unit vector is K. And we know I, J, K, these three unit vectors are known as rectangular unit vector. And here a vector OP vector, that is A vector is equal to OP vector, and O is the tail of the vector and P is the head of the vector, and the coordinate of P point is AX, AY, and AZ. That is, its X coordinate is AX, Y coordinate is AY, and Z coordinate is AZ. So this is our A vector. We will express it with its components. Now we will draw a perpendicular from P point on the XY plane. That is, here PR is the perpendicular on XY plane from P point. Now we will join O point and R point. Here we will draw another perpendicular from R point to OX axis. That is, RM is perpendicular on OX axis from R point. And here NR is perpendicular on Y axis from R point. So OM is the AX, that is the coordinate of P point is AX, AY, and AZ. So OM is equal to AX, ON is equal to AY, and here PR, that is, this is AZ, here Z component. Now this is the figure. Here rectangular box, and this is OP vector, that is A vector, and OM, ON and OS. Here OS is equal to RP. So OS is AZ, OM is AX and ON is AY. That is, the coordinate of P point is OM is equal to AX, ON is equal to AY and OS is equal to AZ. Now, according to triangle law of vector addition, here OP is equal to OR plus RP. According to the triangle law of vector addition, OP vector is equal to OR vector plus RP vector. So OP is equal to OR plus RP. Again, OR is equal to ON plus NR. Here OR vector is equal to ON plus NR. That is, according to the triangle law of vector addition, from this triangle ONR, OR is equal to ON plus NR. So here OR is equal to ON plus NR. And this is equal to ON plus OM. We know NR is equal to OM. So this is ON plus OM. Therefore, OP is equal to ON. Here value of OR is ON plus NR. So that is ON plus OM. ON plus OM plus RP. That is, this is RP. So we can write by rearranging OM plus ON plus RP. RP means OS. Here OS. That is, RP is equal to OS. This is equal to OP vector, that is A vector is equal to, here we know OM is equal to AX and OM vector is AXI, ON vector is AYJ and OS vector is AZK. So this is the representation of A vector in three-dimensional coordinate system, that is A vector is equal to AXI, AYJ plus AZK. Here AX is the X component of A vector, AY is the Y component of A vector and AZ is the Z component of A vector. We know A is equal to AXI plus AYJ plus AZK. Now magnitude of the vector. From the right angle triangle, here right angle triangle ORP, it's a right angle triangle. Here OP square is equal to R square plus RP square. OP square is equal to OR square plus RP square. And also we know OR square is equal to ON square plus NR square. So again, from the triangle ONR, we can write OR square is equal to ON square plus NR square. And this is equal to OP square is equal to ON square plus NR square. Here the value of OR square is equal to ON square plus NR square. So it is ON square plus NR square plus RP square. And we know OP square is equal to ON square plus OM square, because NR square is equal to OM square, and also RP square is equal to OS square. Here RP is equal to OS. So you can write RP square is equal to OS square. So A square is equal to OM means AX. So AX square, and ON means AY square, and OS means AZ square. So A square is equal to AX square plus AY square plus AZ square. Here a square is equal to ax square plus ay square plus az square. Therefore we can write a is equal to root over ax square plus ay square plus az square. Now the unit vector along or parallel to a vector. Here the a vector is axi plus ayj plus azk, and its magnitude is root over ax square plus ay square plus az square. So now unit vector along or parallel to a vector is a is equal to vector a divided by magnitude of a. So it is axi plus ayj plus azk divided by root over ax square plus ay square plus az square. This is the representation of a vector in three-dimensional coordinate system with its components ax, ay and az, and the magnitude of this vector is root over ax square plus ay square plus az square, and a unit vector along this vector is axi plus ayj plus azk divided by root over ax square plus ay square plus az square.